Alright, in this video I'm going to do a similar idea here. We have an object that's suspended. You can imagine a storefront sign like this or something like that, a pole pushing out on the object and a string holding the object up. And what we're going to do is we're going to determine the compression in the pole and the tension in the string. You can imagine from an engineering perspective that this might be important, say if you knew how much weight your string could hold, to determine whether or not the string will be suitable for holding up the sign or whether or not it might break. So here, if it's going to hold up the sign, as in we have static forces, or the object is suspended, then what that means is that the object is not moving. It's not moving, its acceleration is 0, and if its acceleration is 0, then according to Newton's first law, we know that the net force acting on the object is 0. So we're going to do a free body diagram here. There's our 10 kilogram object, and we're going to have a tension that I'll call T in the string and a compression that I'll call C in the pole. And I could put those on their angles, and I could solve the problem using some sort of triangle, but I think that'd be pretty challenging. What I'd rather do is I'd rather break both of those things into their components, and then I can solve the problem independently in each direction. Just like in the last video, what that's going to mean is we'll end up with a system of equations. So let's just get to it. The tension is going up in this direction at an angle of 45 degrees. So there's our tension. And because it's 45 degrees, whether it's the sine or the cos, both of these guys are going to work out to the same value. So the vertical component, 0.707 t, and the horizontal component is the same because the two arms of something that makes a 45 degree angle have to be the same length. So the part of the tensile force going up, 0.707 t, and the part of it going over or horizontally, negative 0.707 t. I put a negative on that because it's in the negative direction. Similarly here, the pole is pushing up with some compression, so let's break that guy apart over here. 30 degrees, C. So this guy's C sine 30, which is 0.5 C. And this guy's C cos 30, which is 0.866 C. So 0.866 C is the horizontal component. 0.5 C is the vertical component. And the force of gravity acting on this is 10 times negative 9.8 newtons per kilogram, or negative 98 newtons. If the net force is 0, it's not just 0 in total magnitude, but it needs to be 0 in the x direction and the y direction respectively. So what I'm going to do is I'm going to use the x and y to come up with my two equations here. In the x direction, the net force is equal to 0, is equal to this negative 0.707 t plus 0.866 c. I'm going to run out of space there. And so what I can get from this is a ratio between my tension and my compression. So I can see that my compressive force is 1.22 times the size of my compressive force. So my tension is 1.22 of my compressions. And then that's good. That's in a nice solved spot. We're going to use that, but let's get the other equation in the y direction. Here, sum of the force is equal to 0. It's equal to the negative 98 newtons plus 0.5 times C plus 0.707 times that tension. Substituting for the tension, so substituting equation 1 and 2. I'll move the 98 newtons over here too while I'm at it. .866. So dividing both sides by 1.366. My compression must be 72 newtons. So if my compression is 72 newtons, I can go back to my original equation and see that my tension is 87.5 newtons. So I've got a tension of 87.5 and a compression of 72 newtons. So again, in a real-world example, we can imagine what if the string was only able to hold something like 50 newtons or something that is 5 kilograms big. Then this 87 newtons would be too much for it and it might break. So by predicting the tension and the compression, we can see if our materials are appropriate for the building that we're using. Once again, we want the object to be static. That means it's suspended. That means acceleration is 0, net force is 0. So I set the net force to 0 in the two directions separately, getting two equations and two unknowns, solving using substitution to find the two values.